Hi everyone, today we will be going through a couple of examples where we will be finding derivatives for logarithmic functions. There are a couple of log laws we always have to remember when dealing with derivatives involving log functions. We must remember that the equation y equals to log base of x is equivalent to exponent y equals x. Also, log base a of a to the power x is equivalent to x. Or, log base a of 1 is equivalent to 0. Or, log of x is equivalent to log base 10 of x. Or, log base a of xy is equivalent to log base of x plus log base of y. Or, log base a of x to the power b is equivalent to b times log base of x. Or, a to the power log base a of x is equivalent to x. Or, log base a of a is equivalent to 1. Or, ln of x is equivalent to log base c of x. Or, log base a of x over y is equivalent to log base a of x minus log base a of y. And log base b of x is equivalent to log base a of x over log base a. It will also be helpful to remember that the derivative of ln of x is equal to 1 over x. And the derivative of log base a of x is equal to 1 over x ln of a. And there are 3 steps that we should always follow when dealing with logarithmic differentiation. First, take the natural logarithms of both sides of an equation and use the laws of logarithms to simplify. Second, differentiate implicitly with respect to x. Third, solve the resulting equation for y prime. Now let's go through a couple of examples. Let's start with this one. We can call it a ln of sin squared of x. We first add derivative notations. We bring the sin exponent to the left of ln and take it outside. Now we will have to apply the chain rule to differentiate ln of sin x. The derivative of ln of sin x gives us 1 over sin x times the derivative of sin x. Simplify. The derivative of sin x will give us positive cosine x. Simplify until we get our final answer of 2 cotangent x. Now let's try this one. We can call it b sin ln of x. We first add derivative notations. Now we will have to apply the chain rule to differentiate sin ln of x. This will give us positive cosine ln of x times derivative of ln x. The derivative of ln x will give us 1 over x. Simplify. And this is our final answer. Now let's try this one. We can call it c 1 over ln of x. We first add derivative notations. Since this is a quotient, we first apply the quotient rule. This then gives the derivative of ln of x over ln of x squared. The derivative of ln of x will give us 1 over x. Simplify until we get our final answer of y prime is equal to negative 1 over x ln of x squared. Now let's try this one. We can call it d ln of x plus the square root of x squared minus 1. We first add derivative notations. We then apply the chain rule. This then gives us 1 over square root of x squared minus 1 plus x times the derivative of the square root of x squared minus 1 plus x. For the derivative of the square root of x squared minus 1, we applied the chain rule, and for the derivative of x, we applied the power rule. We then simplify throughout. Divide both the denominator and numerators with 2 to simplify further. Simplify until we get our final answer of y prime is equal to 1 over the square root of x squared minus 1. Now let's try this one. We can call it b ln of x over x squared. We first add derivative notations. This is a quotient, therefore, we start by applying the quotient rule. This then gives us the derivative of the ln of x times x squared minus ln of x times the derivative of x squared over x to the power 4. The derivative of the ln of x will give us 1 over x, and the derivative of x squared will give us 2x. We then simplify the numerator to get x minus 2x times ln of x. Take x outside as the common factor. Divide both the numerator and denominator by x. We then get our final answer of y prime is equal to 1 minus 2 ln of x over x to the power 3. Now let's finally try this one. We can call it f ln of secant x plus tangent x. We first add derivative notations. Once again we start by applying the chain rule. This then gives us 1 over tangent x plus secant x times the derivative of tangent x plus secant x. The derivative of tangent x will give us secant squared x, and the derivative of secant x will give us secant x times tangent x. We then take out common factors in the numerator to simplify. Then we divide both the numerator and the denominator by tangent x plus secant x, until we get our final answer of y prime is equal to secant x. If you found this video helpful, feel free to hit the like and subscribe buttons below.